Hello, and a very warm welcome to Cognito Key. Have you ever stopped to think about how your gadgets get that perfectly smooth, steady power they need to work? Well, today we're going to pull back the curtain on a tiny but absolutely crucial component that makes it all happen, the pi filter. You see, when we plug our devices in, the power coming from the wall gets converted from AC to DC. The thing is, this conversion is, well, it's not perfect. Instead of a nice, clean line of power, our poor electronics get something more like a bumpy road, what we call pulsating DC. And these little bumps, or AC ripples, can cause all sorts of problems for sensitive circuits. So how do we fix this bumpy road? How do we smooth it out? That's exactly where our hero, the pi filter, comes into the picture. You can think of it like a really, really good shock absorber for electricity. Its whole job is to flatten out those ripples and deliver the clean, stable power that our devices are craving. So what exactly is this thing? At its heart, a pi filter is a really clever team of three components: a capacitor, then an inductor, and then another capacitor. That's it. This simple trio works together perfectly to hunt down and get rid of those unwanted AC ripples. And you might be wondering, why call it pi? Well, the name is actually a huge clue. If you look at it in a circuit diagram, the two capacitors are like the two vertical legs, and the inductor is the horizontal line on top. It literally looks just like the Greek letter pi. Kind of cool, right? Okay, so it looks like a pi, we get it, but how does this simple little shape perform such an important job? It all comes down to a brilliant three-step cleanup process, where each part has a very specific role to play. Let's break it down. All right, step one, the input capacitor. Think of it as a bouncer at a club. It creates an easy exit for most of those AC ripples, diverting them away from the main circuit. But some sneaky ripples might get past, so step two is the inductor coil. This one acts like a roadblock, specifically for AC, blocking anything that the first capacitor missed. And for the grand finale, step three, the output capacitor. It does one final sweep, grabbing any last tiny trace of ripple and sending it to ground. What you're left with is a beautiful, smooth DC output. It's a fantastic little purification system for your power. And that really just says it all, doesn't it? The whole point, the entire goal, is to get that ripple-free DC voltage. And in this department, the pi filter is an absolute superstar. But, in the world of electronics, there's rarely a perfect solution. Nothing is a silver bullet. And for all its amazing strengths, the pi filter has one significant weakness. It's what we call a classic engineering trade-off. So here's the deal. On one hand, the pi filter is fantastic because it gives you high output voltage and gets rid of almost all the ripple. That's awesome. But the catch is that it has what we call poor voltage regulation. Let's unpack what that actually means for us. So let's talk about the good stuff first. The pi filter is great at maintaining a high output voltage because it's just very efficient. Not a lot of power gets lost. And as we just saw, that three-part team of capacitors and an inductor is just incredibly good at cleaning up the signal. So yeah, for filtering, it's top-notch. Now for the drawback. This whole poor voltage regulation thing, what is that? Okay, imagine you're watering your plants with a hose. If you suddenly squeeze the nozzle to spray really far, the pressure right at the tap might dip for a second. It's kind of like that. If the device being powered by the pi filter suddenly asks for a lot more current, the output voltage can drop a lot. And because of this, it's really not a good choice for anything where the power demand is going to be jumping up and down. Okay, so if it has this pretty big limitation, if it can't handle a changing workload, you might be thinking, where do we even use this thing? What's its sweet spot? Well, let's get into the real-world situations where the pi filter's very specific set of skills makes it not just a good choice, but the perfect tool for the job. Its number one home is in communication devices, especially radios. You see, when a radio signal is flying through the air, it's all mixed up with tons of other frequencies and noise. The pi filter on the receiver acts like a super fine comb, carefully separating the one specific frequency you want to listen to from all the other junk. In that job, its amazing filtering ability is what matters most, and its poor voltage regulation isn't really an issue. And that's the pi filter for you, a simple, elegant design that plays such a huge role in our connected world. So what other electronic mysteries do you think we should tackle next? Let me know your ideas in the comments. I'd love to hear them. If you found this explainer helpful and learned something new today, please do me a huge favor and hit that like button, share it with someone who might be interested, and of course subscribe to Cognito K for more deep dives into the amazing world of electronics. Thank you so much for watching.